Hello students and good morning. So today I am doing the same topic, that is first order derivative. So in the last online class also we were doing the same topic, that is first order derivative. So this class is the continuation class of the last online class. Okay. So same exercise 3A, page number 292, and each question carries 2 marks. So let us find out the derivatives of the given function with respect to x. So here the given function is log within bracket ax whole to the power x. Let us assume it as let y is equal to log ax whole to the power x. So now you have to differentiate the logarithmic function. So in this case you should know the properties of logarithm. So I think you have done it in class 11. So let us revise it once again. If there is no base, the base is e. That is, the logarithm of the product of two numbers is equal to sum of their logarithms. That is log a plus log b. That is, it is not only true for logarithm of the product of two numbers, but it is also true for logarithm of the product of more than two numbers. That is, if you have log of ABC, then you can write log a plus log b plus log c. If you have log a, b, c, d, you can write log a plus log b plus log c plus log d. If you have logarithm of the product of n numbers is equal to sum of their logarithms. Is that clear? So this is the first property of logarithm, that is log of ab is equal to log a plus log b, right? Then comes log of a by b, the base is e here. What is the properties? That is logarithm of the quotient of two numbers is equal to difference of their logarithm, that is log a minus log b. So here if there is no base, the base is e, right? Then comes log x to the power n, the base is e, which is equal to, it is n log x base e, right? Then e to the power log x base e is equal to x. So these are the properties of logarithm that you should know it. Okay, so I think you have done it in class 11 also. But if there is log x base e whole to the power n, you cannot simplify it. Is that clear? Log x whole to the power n, log x base e whole to the power n is different from log x to the power n base e. So you cannot write here n log x base e. If log x base e whole to the power n is there, you cannot simplify it further. Is that clear? Log x base e whole to the power n cannot be simplified further. Is that clear? So now let's differentiate it. Okay. So this is log ax whole to the power x. Log ax whole to the power x is there. So you can use property number 3. This is 3. 1, 2, 3, 4 and 4. This one. Okay. So you can use property number 3 here. Here the power is x. X comes in the front. Right. Or y is equal to x log of within bracket ax. Right. If there is no base, the base is e. But you don't have to write this base e. Okay. So or y is equal to x. You can use properties of logarithm here. So within third bracket, that is log of ab. Log of ab is log a plus log b. So likewise, it is log a plus log x. Is that clear? Or y is equal to x log a plus it is x log x. Now this expression is simplified. Now you can easily differentiate it. Now we have to find out the derivative of this function with respect to x. And we have assumed it as y. So let us differentiate both the sides with respect to x, right? So right now, differentiating both the sides with respect to x. Okay? So therefore, it is dy by dx is equal to, now in this case, x into log a. But you know that log a is constant. No need of using UV rule here because one of the term here is constant, that is log A is constant. Only x is the variable here for the first term. But for the second term, x into log x, both are variables. So in this case, you have to use UV rule. Okay. So now since log A is constant, you can write it before d by dx. But it is with the variable x, right? So dy by dx is equal to, it is log A into d by dx of x. Is that clear? But in this case, you can use UV rule because this is the product of two variables, that is x and log x. So use UV rule now. You know UV rule, plus x into d by dx of log x plus now log x is kept as it is, log x into what? Then d by dx of this x. So this is known as UV rule or the product rule. Is that clear now? So let us simplify it. Or dy by dx is equal to, it is only log A because d by dx of x is 1 plus x into, what is d by dx of that log x? 1 by x, you know the formula, plus log x into what? What is d by dx of x? That is 1. That is log x into 1 is log x. So you don't have to write 1 there. Okay. So or dy by dx is equal to, again this is log A plus log B, that is log of AB, right? So this is your log of AX plus, so you can cancel it, x 1 is x, x 1 is x, that means it is 1 upon 1 which is equal to 1. So what is the answer here? It is log of AX plus 1. So this is your final answer. So this is your dy by dx. Okay. So let's do the next problem now. So now we'll do the next question, that is 14 number 5. Find the derivatives with respect to x of the function cot inverse within square root 1 minus sin x upon 1 plus sin x. So let us assume it as y. So you have to find out dy by dx. So before you differentiate it, let us simplify it with the help of inverse circular function. So now in this case, you cannot directly differentiate it. It will be difficult for you to directly differentiate it while calculating, while simplifying, right? So let us simplify the expression on the square root. That is 1 minus sin x is there, it is 1 plus sin x. If you remove the square root, then it will be easier for you to simplify it, isn't it? So let us use the formula now. So y is equal to cot inverse within the square root. Now you know the formula from submultiple angle. What is the formula for sin x? It is 2 sin x by 2 cos x by 2, right? So instead of 1, what will you write? Cos square x by 2 plus sin square x by 2 minus. Now what is the formula for sin x? From submultiple angle, it is 2 sin x by 2 cos x by 2. So this whole divided by. Now in the denominator, instead of 1, what will you write? It is cos square x by 2 plus sin square x by 2 plus. So what will you write for sin x? It is 2 sin x by 2 cos x by 2. Is that clear now? So let us simplify it further now. You know that in the numerator a square plus b square minus twice ab, that is a plus b whole square, and it is a square plus b square plus twice ab, that is a plus b whole square. So let us write down the formula. Y is equal to cot inverse within square root. So it is cos x by 2 minus sin x by 2. This is whole square, whole divided by. Now in the denominator, what do we write? A plus b whole square, right? So cos x by 2 plus sin x by 2 whole square. So this is the simplification, right? So now you can remove square root and square from both numerator and denominator. So what do we write? Therefore y is equal to cot inverse So what do we get now? You can remove square root and square from both numerator as well as denominator. So what do we get? It is cos x by 2 minus sin x by 2 divided by, it is cos x by 2 plus sin x by 2. So is that clear now? Now again you have to use the formula. But if you convert cot inverse into tan inverse, it will be easier for you to use the formula, right? So let us convert this cot inverse into tan inverse. You should know how to convert cot inverse into tan inverse. So while converting cot inverse into tan inverse, the expression within bracket becomes upside down, because cot inverse x is equal to tan inverse 1 upon x, isn't it? So the fraction becomes upside down. Ulta huncha fraction chai. ठीक छ? So or y is equal to, this is your tan inverse. So within bracket what do we get? Numerator goes to the denominator and denominator goes up in the numerator. That means, so it becomes upside down, cos x by 2 plus sin x by 2 divided by, now in the denominator what do we write? It is cos x by 2 minus sin x by 2. So this is the simplified expression. So now you should have the form here, tan inverse tan theta form. If you have tan inverse tan theta, then you can write theta only. Okay. So let us convert this sin x by 2 and cos x by 2 into tan. So here you have to divide both numerator and the denominator by cos x by 2. You know the simplification in the trigonometry, right? So in order to convert this into tan x by 2, you have to divide both numerator and denominator by cos x by 2 and you have to simplify it. So I am directly writing here because you know the simplification, right? So or what is y is equal to? Y is equal to tan inverse. You should divide both the numerator and the denominator by cos x by 2 here, right? So now if you separate the term in both the numerator and the denominator, you will get cos x by 2 divided by cos x by 2 is 1 plus, what is sin by cos? It is tan x by 2 whole divided by what? In the denominator also divided by cos x by 2, it is 1 minus, it is tan x by 2, right? Now again you have to simplify it further, right? Now in this case you have to convert it into tan a plus tan b divided by 1 minus tan a tan b. You know that formula from compound angle. If it is tan a plus tan b divided by 1 minus tan a tan b, you can write tan of a plus b. So in the numerator, instead of 1 here, you should write tan pi by 4. So or y is equal to tan inverse within bracket, it is tan pi by 4 plus tan x by 2, this whole divided by 1 remains same, 1 minus, actually tan x by 2 is 1 into tan x by 2, isn't it? So instead of 1, what do we write? It is tan pi by 4 then tan x by 2, alright? So bracket is closed. Now which formula is here? Tan a plus tan b divided by 1 minus tan a tan b. Here a is pi by 4 and b is x by 2. So or y is equal to tan inverse. So it is tan of a plus b, that is pi by 4 plus x by 2, right? So or y is equal to, what is tan inverse tan x? It is only x, but here you can write pi by 4 plus x by 2. Pi by 4 plus x by 2. Now you can easily differentiate it. So this is the simplified form of the given expression. Okay. So let us write differentiating both the sides with respect to x. So therefore dy by dx is equal to, you don't have to write dy by dx on the right hand side, okay? What is dy by dx of pi by 4? 0, you don't have to write. What is dy by dx of x by 2? Now half is constant here and half is with the variable x. So you can write down half before dy by dx. Half into dy by dx of x, right? For pi by 4 it is 0, no need of writing it. Plus half is constant but x is the variable. Half comes in the front of dy by dx. So half into dy by dx of x. Is that clear? Next. So now, therefore dy by dx is equal to half. And what is dy by dx of x? That is 1. So half into 1 is always half. So half is the answer. Is that clear? So we can copy it. We'll do the next one. So now we are doing the next question, that is 14 number 6. Find the derivatives with respect to x of this given function. That is 2x plus 1 whole divided by x cube minus log of tan x plus x sine inverse x square. So let us assume here also y. So let y is equal to 2x plus 1 whole divided by x cube minus log of tan x plus x sine inverse, this is your x square, right? So let us differentiate both the sides with respect to x. So you have to write down differentiating both the sides with respect to x, right? So therefore it is dy by dx is equal to, now in the first term you have to use u by v rule. You know u by v rule, isn't it? So denominator is kept same, x cube into, you have to differentiate the numerator, that is 2x plus 1 with respect to x. Then comes minus sign. Now which function is kept as it is, that is numerator, that is 2x plus 1 is kept same. You have to differentiate the denominator, that is d by dx of x cube. This whole divided by what? Denominator whole square. That is the rule, u by v rule or quotient rule, right? So denominator whole square here is x cube whole square. So you did this quotient rule or u by v rule of differentiation in class 11, right? Then minus. No need of writing dy by dx of log of tan x. Just differentiate directly. So it is in the form log x now. What is the differentiation of log x? 1 by x. But here what is x? Tan x. So it is 1 by tan x. Right? Into, again we have to differentiate the function which is assumed as x. This tan x was assumed as x. So what is this differentiation? It is sec square x. Is that clear? So it is 1 by tan x into, what is the differentiation of tan x? It is sec square x. Plus, next, now we have to use uv rule here, product rule. So let us use product rule. X is kept as it is, d by dx of what? D by dx of it is sine inverse x square, right? Plus, now you have to keep sine inverse x square same, but you have to differentiate the function x, okay? So it is sine inverse x square into, it is the continuation part, right? Since there is no space there, I am writing in the next step, that is d by dx of x. So it is d by dx of x. Is that clear to all of you? So this is the differentiation. Now you have to simplify it. Okay? So or it is dy by dx is equal to x cube into, what is d by dx of 2x? 2 is with the variable. 2 constant is with the variable x. So 2 comes in the front. 2 into d by dx of x. What is d by dx of x is 1. So 2 ones are 2. So 2, okay, what is d by dx of 2x? It is only 2 plus, what is the differentiation of 1 with respect to x? That is 0. So only 2 remains here. So what is d by dx of 2x plus 1? It is only 2 minus 2x plus 1 into, what is the differentiation of x cube with respect to x? It is 3x square. 3 comes in the front and decrease the power of x by 1, that is x square. So whole divided by, this is x to the power 6, that is 3 to the 6, right? Minus, let us simplify it. What is 1 by tan x? Cot x, cot x means cos x by sin x into, what is sec square x? 1 by cos square x, right? So let us differentiate the next part, x into, so how can we differentiate sin inverse x square with respect to x? You have to take it as first sin inverse x. What is the differentiation of sin inverse x? 1 upon root over 1 minus, what is x here? X square whole square into Now which function was taken as x? X square. You have to differentiate again that x square, okay? So what is the differentiation of x square? It is 2x, right? Then plus, what is d by dx of x? That is 1. You know that, isn't it? D by dx of x is 1. So 1 into sine inverse x square. This is sine inverse x square. Is it clear now? So let us simplify it once again. Or dy by dx. So dy by dx is equal to 2x cube. It is 2x cube minus minus, this is 3 2s as 6x cube. It is minus 6x cube minus into plus minus, that is 3x square. So whole divided by, this is x to the power 6. Okay, here you can cancel cos x and square gets cancelled. You will have sin x into cos x. But if there is sin x into cos x, if you multiply that sin x into cos x by 2, you can use the formula from multiple angles. That is 2 sin x cos x is equal to sin 2x. So let us multiply both numerator and the denominator by 2 here, right? So 2 upon, it is 2 sin x cos x, right? Then plus, what is the next term? Plus 2x into x, 2x squared divided by, in the denominator, root over 1 minus, what is x square? Whole square, that is x to the power 4, right? And then the last one is, what is the last one? Plus sine inverse x squared. So it is sine inverse x squared, right? So now again you have to simplify it. So now what is dy by dx? So now dy by dx is equal to, what is 2x cube minus 6x cube? Different sign you have to subtract, and you have to write down the sign of the greater number, that is minus 4x cube minus 3x squared whole divided by x to the power 6 minus 2 divided by, what is 2 sin x cos x? This is sin 2x. You can simplify it further, right? So these two terms remain same, that is 2x squared divided by root under 1 minus x to the power 4 plus, this is your sine inverse x squared, right? So once again you can simplify it, or dy by dx अझै हामी यसलाई simplify गर्दै लान्छौं. So dy by dx is equal to, in the numerator what is common there? Minus x square is taken common. So within bracket what do we get? It is 4x, right? So minus into minus plus 3 whole divided by, this is your x to the power 6. Then minus 2 into, you can write here, what is 1 by sine 2x? Cosec 2x, isn't it? So it is cosec 2x plus 2x square whole divided by 1 minus root under 1 minus x to the power 4 plus it is sine inverse x squared. Now let us write down the final answer. So here you can cancel x squared with x to the power 6, that means x to the power 4. So x to the power 6 is cancelled by x squared, which is equal to x to the power 4 here, isn't it? So when this x squared goes to the denominator, it becomes minus 2. What is 6 minus 2? That is 4. So it is x to the power 4, right? So or dy by dx is equal to minus, within bracket, 4x plus 3 whole divided by x to the power 4 minus 2 cosec 2x plus, next third term, what is the third term here? It is 2x squared divided by root under 1 minus x to the power 4, right? And then plus, what is the term? That is sine inverse x squared. So this is the final answer. Okay? So I think you have understood it. You can copy it. Now we'll do the next question now. So now do the next question, that is find the derivatives with respect to x. That is 15 number 1. You have to differentiate. You have to find out the derivatives of log x base a with respect to x. Now here the base is different. If you are given only log x, then the base is e. You could have easily differentiate it when the base is e. That is, there is direct formula. Log x base e को differentiation कति हुन्छ 1 upon x. But in this case, the base is other than e here. That is, base is a. So you cannot differentiate it directly. Okay. So the method is, let us write down let y is equal to. So let y is equal to, it is log x base a. But always you have to make the base e. Log को base चाहिँ जहिले पनि तिमीले e नै बनाउनु पर्छ अनि मात्रै त्यसलाई डिफरेन्शिएट गर्न सक्छौ. That is, d by dx of log x base e will be equal to, it's only 1 by x, right? त यहाँ हामीले base e बनाउनै पर्छ. त के गर्नु पर्छ भन्दाखेरि, so if there is log a base b, so you can write it in terms of fraction also. If there is log a base b, so you can write it as log a divided by log b. So I told you that if there is no base, the base is e there. You can write base e there, or you don't have to write base e. Okay. So log a base b means log a divided by log b. Similarly here also you can write y is equal to log x divided by log a. Right. So now you can write down the base here. The base is e. Now we have made log x as base e. Now you can easily differentiate it. So what is log a base e now? What is log a base e? Log a base e is constant. So this log a base e can be taken to the numerator. So what happens, log a base e, when you take it to the numerator, like if it is 1 upon log a base e, then you can write 1 upon, this is your log a upon log e, isn't it? Because this log a base e can be written in terms of fraction, right? So when this denominator goes up in the numerator, it becomes upside down, you know that. So it is log e divided by log a is equal to. So you can write it in terms of base form. So it is log e base a. So it is log e base a. So whenever this term, that is log a base e, goes up in the numerator, it becomes log e base a. Directly you can write it. Is it clear now? If this log a base e goes up in the numerator, we have simplified here. Directly you can write just ulta huncha yo, that is log e base a. Similarly, when this log a base e goes up in the numerator, it becomes log e base a, right? So y is equal to, this is log e base a, right? Log a base e, when it goes up in the numerator, it becomes log e base a. Likewise, it is also log e base a into log x base e, right? So now let us differentiate it with respect to x. So write down. Let us write differentiating both the sides with respect to x. Differentiating both the sides with respect to x. Now you know that this log e base a is free from x, so it is a constant quantity. So therefore dy by dx, so you can write down this log e base a in front of dy by dx. So it is log e base a into what? D by dx of this is log x base e. Is it clear to all of you? So what is d by dx of log x base e? It is 1 upon x. So or dy by dx is equal to log e base a into 1 upon x. Okay. So or you can write dy by dx 1 upon x. You can write it before log e base a. So 1 upon x, and it is log e base a. So this is the final answer. Is that clear? So what is the differentiation of log x base a? It's not only 1 upon x, that is wrong. Okay. So what is d by dx of log x base a? Log x base a, it is 1 upon x into log e base a. Is it clear now? So you can copy it. This is very, very important. Okay. So we'll do the next question now. So now we'll do the next question, that is 15 number 2. This is also very, very important. Now it is given log e base x but not log x base e. If it is given log x base e, you could have easily differentiate that log x base e, that is 1 upon x, but it is given log e base x. But you should make it log x base e first. Okay. Just now I told you about if it is log a base e, you can write log a upon log e, isn't it? Right? Let us take that log a to the denominator. So it becomes 1 upon log e divided by log a. Right? So which is equal to 1 upon, now this denominator can be written in terms of base form. Log e base a. That is, what can we learn from here? If there is log a base e, if you want to take it to the denominator, it becomes 1 upon log e base a. Take it down. Okay? If you want to take this log e base a to the numerator, it becomes log a base e. If it is taken to the denominator, it becomes 1 upon log e base a. Is that clear to all of you? So here also you have to make it log x base e. So that means you have to take this term to the denominator. So what does it become? Y is equal to 1 upon, this is your log x base e. So we are using this simplification. Is that clear? So log e base x, when it goes to the denominator, it becomes 1 upon log x base e. But in this case, while differentiating, you don't have to use u by v rule here, because one of the term that is in the numerator, it is constant. So let us take log x base e to the numerator. But you cannot write this log e base x. But you can write, you know that 1 upon x means x to the power minus 1. That is x whole to the power minus 1. Similarly, you can take this log x base e to the numerator. So it becomes what? You should write here inverse. That is log x base e whole to the power minus 1. Now you can differentiate it. So write down, differentiating both the sides with respect to x. Differentiating both the sides with respect to x. Okay. So therefore dy by dx, now we can easily differentiate it, directly differentiate it. What is dy by dx of log x base e whole to the power minus 1? First of all, you should take it as x to the power n, because your power minus 1 is constant and log x base e is the variable. That variable should be taken as x. So it is in the form x to the power n. So what is the differentiation of x to the power n? N into x to the power n minus 1. But in this case, what is n? It is minus 1 within bracket. What is x in this case? Log x base e whole to the power, decrease the power by minus, decrease the power by 1. Decrease the power by 1 means minus 1, that is minus 2. But again you have to differentiate the term which was assumed as x. In this case, log x base e was assumed as x. That log x base e should also be differentiated. That means dy dx of log x base e. किनभने यो log x base e लाई नै हामीले x सम्झेर x to the power n फर्मुला लगाएको हो हैन। त जुन चाहिँ x सपोज गरिएको छ त्यो फंक्सनलाई हामी फेरि डिफरेन्शिएट गर्नै पर्छ। That is into dy by dx of log x base e, right? So or dy by dx is equal to minus, what is log x base e whole to the power minus 2? It is 1 upon, this is your log x base e whole square. It is simplified. It is taken to the denominator. We are making the power positive. So into, what is dy by dx of log x base e? It is 1 upon x. Is that clear? So or dy by dx or dy by dx is equal to minus 1 upon x into log x base e whole square. So this is the final answer, right? So what is the differentiation of log e base x? It is minus 1 upon x into log x base e whole square. So this is your final answer. So this is very important question. So you can copy it. We'll do the next question now. So now we'll do the next question, that is 16 number 1. You have to find out the derivatives with respect to x of the function x to the power x. Now it is given x to the power x. So in this case, which formula is used? Will you use x to the power n formula? No. In this case, x is the variable but power is a constant. But in this case, base is variable, power is also variable. So you cannot use that x to the power n differentiation, right? Will you use a to the power x form? In this case, this base a is a constant but power is the variable. But in this case, base is the variable, power is also the variable. That means both base and the powers are the variables in the given problem. So you cannot use this formula, right? We cannot use this formula, right? So if the base and the powers are both the variables, you have to use logarithm because this power should be taken in the front. This power should be taken in the front. Okay? So how can you take that power in the front? You have to take log, isn't it? Because you know the properties of logarithm, that is log x to the power n is equal to what? It is n log x, right? So if you write log here before x to the power x, if you can write log out there, this power x comes in the front of log, isn't it? So you have to take logarithm in this case. So if you take logarithm on the right hand side, you should take logarithm on the left hand side also. Is that clear? So let us assume let y is equal to x to the power x. Now write down taking log on both the sides. Taking log on both the sides. So हामीले log किन लिँदैछौँ भने तिमीले यो दुईतिरै log लिनुपर्छ किनभने x to the power x को डाइरेक्ट डिफरेन्सिएसन छैन बुझ्नु छैन त्यसमा d by dx of x to the power n फर्मुला पनि युज हुँदैन d by dx of a to the power x पनि फर्मुला युज हुँदैन किनभने x to the power n मा जुन चाहिँ पावर n छ that is constant अनि a to the power x मा जुन चाहिँ constant a छ base a छ that is also a constant तर यसमा चाहिँ power र base दुईटै variable भएको कारणले गर्दा you cannot use that formula. Is that clear? That means in this case you have to take log on both the sides. Log लगाए मात्रै power x के हुन्छ अगाडि आउँछ हैन? So let us take log on both the sides. So therefore it is log y is equal to log x to the power x. You can write base e also, or you don't have to write that base e. Okay? So if there is no base e there, it is understood that the base is e out here, right? So or log y is equal to, or log y is equal to x comes in the front. This is x log x, right? So now you can differentiate both the sides with respect to x. So right now differentiating both the sides with respect to what? X. That means this is your d by dx of log y is equal to d by dx of x log x. So no need of writing again d by dx, just differentiate directly. Okay, so in this case also I have written it d by dx, but you don't have to write, no need of writing this d by dx again and again, right? So let us differentiate it. You can directly differentiate it. You could have directly differentiated it, right? So now, or what is d by dx of log y? First of all, take it as log x because we are differentiating with respect to x. Let us take it as log x first. What is the differentiation of log x? 1 upon x. But here it is 1 upon y. Again you have to differentiate the function which is assumed as x. In this case y is assumed as x. You have to differentiate y with respect to x. What is the differentiation of y with respect to x? It is dy by dx, isn't it? So it is dy by dx is equal to. Now on the right hand side, x log x is there. Which rule is used? Now x is kept as it is. Now what is d by dx of log x? 1 by x, you know that. Plus now log x is kept as it is into. Now we have to differentiate x with respect to x. That is always 1. So directly you can write 1 out. Okay. So here x1s are x, x1s are x, or 1 upon y into dy by dx is equal to, it is only 1 plus log x. Now you can easily find out the value for dy by dx, but we need here only dy by dx, isn't it? Now y is taken to the right hand side, cross multiply. So y into 1 plus log x. Okay. But on the right hand side, because we have assumed y is equal to x to the power x, so on the right hand side, the value of y, you should substitute the value of y. What is the value for y here? X to the power x. So on the right hand side, you have to substitute the value of y. Or dy by dx is equal to, what was the value for y? It is x to the power x. It is x to the power x within bracket. It is 1 plus log x. So this is the final answer. So what is the derivative of x to the power x with respect to x? It is x to the power x and within bracket 1 plus log x. So that is your final answer. Now we'll do the next question. So now we'll do the next question, that is 6 number 3. Find the derivatives with respect to x. Okay, so you have to find out the derivative of this function with respect to x. That is 2 to the power x plus 2 minus e to the power x plus 1 plus log x base 10. You can directly differentiate it. This is just like here 2 is constant, a to the power x, x plus 2 is assumed as x. This is a to the power x form. This is e to the power x form. X plus 1 is taken as x. Okay. And this is, you should write it in terms of base e. That is, you should write it in terms of what? Fraction. Right? Log x base 10 in terms of fraction is log x divided by log 10. Right? So, or y is equal to, this is 2 to the power x plus 2 minus e to the power x plus 1 plus, this is your log x divided by log 10, because in this case you cannot directly differentiate it because here the base is 10. So now it is base e, right? So or y is equal to 2 to the power x plus 2 minus e to the power x plus 1 plus, now we can take that log 10 base e to the numerator. So what does it become? You know that it becomes log e base 10 into, it is log x base e, right? So let us differentiate both the sides with respect to x. Okay, so differentiating both the sides with respect to x. Okay, so let us differentiate it. Therefore dy by dx is equal to, now अब तिमीले घरिघरि dy by dx लेखिरहनु पर्दैन, directly differentiate गरौँ ल यसलाई. So now what is d by dx of 2 to the power x plus 2? You should take it as a to the power x, because 2 is constant here, base is constant and power is a variable. That means you have to take it as a to the power x. What is the differentiation of a to the power x with respect to x? It is a to the power x log a base e. But in this case it is, what is a? 2, what is x? X plus 2, what is log a base e? Log 2 base e. But which function was taken as x? That is power. X plus 2 was taken as x. You have to differentiate that term which is assumed as x. That is, you have to differentiate x plus 2 again. So d by dx of x plus 2. Is that clear to all of you? Next, minus. What is d by dx of e to the power x plus 1? It is just like your e to the power x. Which function is taken as x? X plus 1. What is the differentiation of e to the power x? It is e to the power x, but here it is e to the power x plus 1. Again, you have to differentiate the function which is assumed as x. Which function was assumed as x? X plus 1. That x plus 1 should also be differentiated. Okay? That means dy dx of x plus 1. Right? As there is no space there, let us write it in the next step for the third one. Plus, you know that among these two, log e base 10 and log x base e, log e base 10 is constant. You can write it before d by dx, that is differentiation, right? That is log e base 10 remains same into, what is d by dx of log x base e? You have to differentiate the variable only. What is the differentiation of log x base e? It is what? 1 upon x. Is it clear now? So let us simplify it. Or dy by dx is equal to, now what is d by dx of x plus 2? Can you tell me? That is d by dx of x is 1 always, plus what is d by dx of constant? 0. What is 1 plus 0? 1. That means you will get only 2 to the power x plus 2 into log 2 base e. Because d by dx of x plus 2 is 1 plus 0, which is equal to 1. Right? So 1 is there, so you don't have to write 1. Similarly, what is d by dx of x plus 1? That is also 1. Because d by dx of x is 1 plus d by dx of 1 is 0. So 1 plus 0 is always 1. So 1 into e to the power x plus 1, that is minus e to the power x plus 1. Is that clear? So this is your second term. Then last one is plus 1 upon x log e base 10. Is that clear to all of you? Now this is the final answer. So I think you have understood it. So we'll do the next problem now. So now, before I do the next problem, let us discuss about 3 different types of functions, right? 3 different types of functions. Functions, or it may be equations also, right? So number 1 is explicit function. Number 1 is explicit function, right? Number 2 is implicit function. Implicit function. And number 3 is parametric function. And number 3 is parametric function. So there are 3 different types of functions. Number 1 is known as explicit function. Number 2 is implicit functions, and number 3 is parametric functions. So let us discuss about explicit function. What type of function is known as explicit function? If you can express y as a function of x, that is, if we can express y is equal to f of x, that is y is equal to f of x. You may write y is equal to x cubed plus x square plus sin x plus cos x plus 1, etc. Or you may write, or y is equal to log x plus e to the power x plus sin inverse x, and so on. So if you can write y in terms of x, that is generalized, you can generalize it, y is equal to f of x. So if you can write the function y, if you can write y as a function of x, then this type of function is known as explicit function. So till now we were doing the differentiation of this explicit function. That is, suppose there was x to the power x was given, e to the power x was given, that was assumed as y, isn't it? If we want to differentiate x to the power x, we have assumed y is equal to x to the power x, that is y is equal to f of x was there, isn't it? So this type of function is known as what? Explicit function. Understood? So number 2 is what? Implicit function. Implicit function. So what type of function is known as implicit function. Like if you have f of within bracket x by y is equal to some constant c. Like example is x to the power 4 plus x square y square plus y to the power 4 is equal to 0. It may be y square is equal to 4ax is equal to 0. It may be x square by a square plus y square by b square is equal to 1. Okay, so this is the relation between x and y. If there is a relation between x and y, okay, so if there is a relation between x and y given by x to the power 4 plus x square y square plus y to the power 4 is equal to 0, or if there is a relation like this, it may be y square is equal to 4ax. If the relation between x and y are given by this equation, if the relation between x and y is given by this equation, that is y square is equal to 4ax, right? Or the next example, x square by a square plus y square by b square is equal to 1. There is another type of example, that is x cube plus y cube is equal to 3axy, right? So if there is a relation in terms of x and y, then, or if you can write f of within bracket x, y, that is function of x, y, that is relation in terms of x and y. Function of within bracket x, y, it is read as function of within bracket x, y. Now if you get the relation between x and y, then that relation is known as the implicit function and the equation is known as the implicit equation. So these are all examples of implicit equation, right? Like if you have got a relation between x and y, or f of within bracket x or y is equal to some constant is there, then this type of function is known as implicit function and the equation is known as implicit equation, right? So next one is number 3 is parametric function. Parametric function. So what type of function is known as parametric function? Suppose we have y is equal to f of x and z is equal to let us say phi of x. Okay, so in this case y and z are the two variables and they are expressed in terms of a third variable x. So usually we take x and y as a variable. Let us write it as x is equal to f of z and y is equal to phi of z. So here x and y are the two variables and this x and y are expressed in terms of a third variable z. So in this case this z is known as a parameter. This z is known as what? It is known as a parameter, and this type of function is known as parametric function or the parametric equation. So if you can express x and y variable as the third variable z, where z is known as a parameter, then this type of function is known as parametric function and the equation is known as the parametric equation. Is that clear now? So example is x is equal to a cos theta, comma y is equal to b sin theta, right? So in this case a and b are constant, not the variable. These are constant. This x and y are the variables and this theta is the third variable which is also known as a parameter. यो theta लाई चाहिँ हामी third variable पनि भन्छौं अर्थात parameter पनि भन्छौं. अर्थात के पनि भन्छ भने यसलाई parameter भनेर पनि भन्छौं. त्यही कारणले गर्दा यो फंक्सनलाई हामी parametric function पनि भन्छौं अर्थात parametric equation पनि भन्छौं. त अर्को पनि छ example of parametric equation. X is equal to 80 square comma y is equal to 280. In this case this a and 2a are constant and t is a parameter here or the third variable, and this equation is known as parametric equation or function is known as parametric function. So what type of function is known as a parametric function? If the two variables x and y are expressed in terms of a third variable z, where z is a parameter, then this type of function is known as parametric function and the equation is known as the parametric equation. So I think you know about explicit function, implicit function and parametric function. Is that clear to all of you? So you have to understand it only, but you have to differentiate all these functions. Now we'll differentiate implicit function, right? So now let's do the next question, that is number 17. You have to find out dy by dx, that is find dy by dx, right? So this will be find dy by dx if this one. You know what type of function is this one, but in the examination you won't get the question like what do you mean by implicit function, what do you mean by explicit function, what do you mean by parametric function, but you should know the function, that is, it is implicit function, it is explicit function, it is parametric function, but the definition are not asked in the question paper, okay? But it will be better if you know the functions, okay? So number one, x square plus y square is equal to 4. What type of function is this one? Implicit function, because x and y are connected by a relation out here, isn't it? So this is implicit function. So you have to differentiate this with respect to x, because you have to find out dy upon dx. Upon dx is there, that is with respect to x. That means dy by dx means only x and y are the variables here, and all other terms are constant in this case. Other than x and y, all other terms are constant here, okay? So you have to find out dy by dx from this implicit function, right? So directly you can write differentiating both the sides with respect to x, okay? So therefore, what is the differentiation of x square with respect to x? 2x plus, and d by dx of x is 1, you don't have it right here. Now this is y square, but you are differentiating it with respect to x. First of all, take it as x square. What is the differentiation of x square to x? But here it is 2y. Again you have to differentiate the function which is termed as x, that is, here y is assumed as x. So you have to differentiate y with respect to x. That means it is dy by dx, which is equal to, what is dy by dx of 4? It is always 0. That is your constant, isn't it? So let us get the value for dy by dx, or you have to solve for dy by dx. So 2y dy by dx is equal to minus 2x. Your 2 gets cancels. Or what is the value for dy by dx now? Which is equal to minus x upon y. In this case, you don't have to write down the value for y, because y is given in the question itself. Okay, so this is your final answer. Is it understood? So let's do the next question. That is number 3. 17 number 3 is, so 17 number 3 is, it is given x cube plus y cube plus 3axy. X cube plus y cube is equal to 3axy. So this is also the relation in terms of x and y. This is an implicit function, and the equation is known as the implicit equation. So let us differentiate it directly, okay? So differentiating both the sides with respect to x, okay? So now, what is d by dx of x cube? You have to differentiate both the sides with respect to x. What is d by dx of x cube? It is 3x square plus, what is the differentiation of y cube now with respect to x? It is 3y square into dy by dx is equal to 3a is constant. You can write it before brackets, before differentiation of xy. You can write 3a before differentiation of x into y, so within bracket. Let us differentiate xy. This is the product of two different functions. So you can use UV rule. X is kept as it is into y for differentiation. Dy by dx with respect to x, dy by dx plus y is kept as it is into, what is d by dx of x? It is always 1. So second bracket is closed. Now you have to solve for dy by dx, because you have to get the value for what? Find dy by dx. Or 3x square plus 3y square into dy by dx is equal to, now multiply by 3a out there. What is it? 3ax dy by dx plus it is 3ay, right? So it is 3ay. So let us find out the value for dy by dx. Now you can keep the terms containing dy by dx on the left hand side and all other terms to the right hand side. That means or 3y square into dy by dx, then minus 3ax into dy by dx, which is equal to, on the right hand side, what do we write? Now 3ay, then take this one 3x square to the right hand side, so it is minus 3x square. Is it clear? Now you can take common. So what is common on the left hand side? 3 into dy by dx. So within bracket what do we get? Y square minus ax is equal to, right? So on the right hand side what is common over there? 3 common within bracket ay minus x square. Is that clear? So on the right hand side only 3 is taken common here. So from both the sides you can cancel these common terms. 3 gets cancels. Or what is the value for dy by dx now? So dy by dx is equal to ay minus x square. So when this term, that is y square minus ax on the left hand side, when it goes to the right hand side, you should write it in the denominator, divided by y square minus ax. So this is your final answer. Understood? So you can copy it. Now we'll do the next question now. And so now we'll do the next question, that is, this is also implicit function type. Find dy by dx, that is number 4. The equation is x to the power 2/3 plus y to the power 2/3 is equal to a to the power 2/3. So in this case x to the power 2/3 and y to the power 2/3 is the variable, are the variables, and a to the power 2/3 is a constant. So let us differentiate it. So differentiating both the sides with respect to x, okay? So what is the differentiation of the first term? This is just like x to the power n. 2/3 comes in the front, x to the power 2/3 minus 1, right? N into x to the power n minus 1. Similarly, plus, what is the differentiation of y to the power 2/3 with respect to x? It is 2/3 y to the power 2/3 minus 1, but you have to differentiate y with respect to x because we are differentiating both the sides with respect to x. That is dy by dx, which is equal to, what is dy by dx of a to the power 2/3? That is a constant, it is always 0. So, or this is 2 by 3 x to the power minus 1/3, isn't it? 3 ones are 3, 2 minus 3 is minus 1/3 plus 2 by 3 y to the power minus 1/3 into dy by dx, which is equal to 0. Is that clear? So next, what will you do? 2/3 x to the power minus 1/3, 2 should be taken to the right hand side, and you have to get the value for dy by dx, or 2/3 y to the power minus 1/3 into dy by dx is equal to. Now this is taken to the right hand side. So what does it become? Minus 2/3 x to the power minus 1/3, right? So from both the sides you can cancel this common term 2 by 3, or y to the power minus 1/3 into dy by dx is equal to minus x to the power minus 1/3, right? So what is the value for dy by dx? So dy by dx is equal to minus x to the power minus 1/3 divided by y to the power minus 1/3. Or you can write down the answer here, or you may again simplify it further. Or dy by dx, since the power is minus here, you can take that y to the power minus 1/3 to the numerator, so it becomes y to the power plus 1/3, and x to the power minus 1/3 can be taken to the denominator, becomes x to the power 1/3. Since the powers are same here, you can write minus y by x whole to the power 1/3. So this is the final answer. Is it understood now? So you can copy it. We'll do the next one. So now we'll do the next question, that is number 17. Find dy by dx. So number 5. So it is given x square upon a square plus y square upon b square is equal to 1. You know that in class 11 you did coordinate geometry. In coordinate geometry there is an ellipse. So this is the equation of an ellipse. X square upon a square plus y square by b square is equal to 1. Right? So let us find out dy by dx from here. Okay? So differentiating both the sides with respect to x. So therefore 1 upon a square is constant. You should write it before dy by dx. 1 upon a square is constant. What is dy by dx of x square? 2x plus 1 upon b square is again here constant, isn't it? What is the differentiation of y square? It is 2y into dy by dx, which is equal to differentiation of 1 is always 0. Is that clear? So let us simplify it further, or let us take this 2x by a square to the right hand side. So 2y upon b square into dy by dx is equal to, this is taken to the right hand side. So what does it become? Minus 2x upon a square. From both the sides you can cancel this 2, right? So what is the value for dy by dx? So dy by dx is equal to what? Minus sign is there. You have to cross multiply b square by x. What is it? It is b square upon x divided by, you have to cross multiply y by a square. So what is here? It is a square y. So this is your final answer. So what is the value for dy by dx in this case? Dy by dx is equal to minus b square x upon a square y. Okay. Now similarly you can do this problem. You do it at home. That is, find dy by dx if number a, x square upon a square minus y square by b square is equal to 1. You know that this is the equation of a hyperbola. Your hyperbola equation ho. And number b पनि गर्नु, y square is equal to 4ax. This is the equation of the hyperbola. You can differentiate both these sums, that is a and b. This is the equation of a hyperbola. This is the equation of a parabola. You can differentiate it. Okay? You have done it in class 11, isn't it? So you have to find out dy by dx for both this implicit function. Okay? So this is your homework, right? So now we'll do the next question. You can copy it. Now we'll do the next question, that is 17, number 7. Here also you have to find out dy by dx. This is also an implicit function. The given function is ax square plus 2xxy plus by square plus 2cx plus 2fy plus c is equal to 0. Since you have to find out dy by dx, x and y are only the variables here, but all other terms are constant. That means a, h, b, g, f, c are all constant, including that 2 also, right? So directly you can differentiate it. So differentiating both the sides with respect to x, right? So therefore, what is the differentiation of ax square? A is constant. A into 2x, that is 2ax plus 2h within bracket x into y is there. You have to use UV rule, right? X into what? dy by dx plus y into, what is the differentiation of x? That is 1. You don't have to write 1. Y into 1 is y. Plus, what is the differentiation of y square now with respect to x? It is 2y, but it is 2by into, again differentiate y with respect to x, that is dy by dx, right? Y को differentiation with respect to x पनि गर्नुपर्छ यहाँ, that is dy by dx plus 2z into, what is dy by dx of x? 1, you don't have to write it, plus 2f into what is the differentiation of y with respect to x? It is dy by dx. Now plus c is there, only c is there, no variable out there. What is the differentiation of c? What is dy by dx of c? That is 0. Do not write it, which is equal to 0. Is that clear? Now let us simplify it. Or this is 2ax plus multiply by 2h, 2hx dy by dx plus 2hy plus 2by into dy by dx plus 2z plus 2f dy by dx is equal to 0. Is it clear to all of you? Now what is to be done here? You have to find out the value for dy by dx. So now keep the terms containing dy by dx on the left hand side and all of the terms take them to the right hand side. Okay, that means all of the terms means the terms which do not contain dy by dx, take them to the right hand side. Okay, so let us simplify it. 2hx dy by dx plus 2by into dy by dx plus 2f dy by dx. 2f dy by dx. Is that clear? Is equal to. Now the terms which do not contain dy by dx, take them to the right hand side. So it becomes minus 2ax. 2ax on the right hand side becomes minus 2ax, then 2hy minus 2hy and then minus 2z. Then it is minus 2z. Is that clear? So next. Or what is common on the left hand side? You can take common here. 2 dy by dx is common. So here 2 dy by dx is taken common. So within bracket, what do we get? hx plus by plus f, because 2 into dy by dx is taken common, is equal to, on the right hand side, what is common there? Minus 2 within bracket ax plus hy plus g. Here minus 2 is taken common out here, isn't it? ax plus hy plus g, bracket is closed. So from here these two gets cancels. Common term can be cancelled, that is 1 1, 2 1s are 2, 2 1s are 2, right? So what is the value for dy by dx now? So dy by dx is equal to what? Minus within bracket ax plus hy plus g whole divided by hx plus by plus f. So this is the final answer. Understood? So minus in the numerator we have ax plus hy plus g whole divided by hx plus by plus f. That is your answer. So we'll do the next question now. So now we are doing the next question, that is 17 number 8. Here also implicit function is given, you have to find out dy by dx. Okay, so before differentiation let us simplify it. Okay, so how will we simplify it? Or a plus b whole square, isn't it? What is a whole square? X square whole square plus 2 into what is a? X square, what is b? Y square. That is 2ab plus what is b whole square? Y square whole square. Right? That is your a square plus 2ab plus b whole square. Here a is x square and b is y square. Is equal to xy. Right? Or this is x to the power 4 plus 2x square y square plus y to the power 4 is equal to xy. Now you can differentiate both the sides with respect to x. So let us write here, differentiating both the sides with respect to x, right? So what is d by dx of x to the power 4? It is 4x cube plus here 2 is constant within second bracket. X square into y square is there. You have to use the product rule. That is UV rule, right? X square is kept as it is. What is the differentiation of y square with respect to x? 2y into dy by dx plus Now y square is kept as it is into what is the differentiation of x square? It is 2x. So here second bracket is closed. Plus next, what is the differentiation of y to the power 4? It is 4y cube into, but we are differentiating it with respect to x, so it is dy by dx, right? Which is equal to, now on the right hand side, x into y is there. You have to use again UV rule. So x into y co-differentiation with respect to x, it is dy by dx. Plus y into, what is dy by dx of x? It is 1. Actually, you don't have to write 1 because y ones are y, isn't it? So let us simplify it further now. So, or this is 4x cube, right? Now multiply by 2 here, plus 2 2s are 4, x square y into dy by dx, right? So plus into plus, plus this is 2 2s are 4, xy square, plus 4xy square, is that clear? 4x square y divided x plus 4xy square plus 4y cube plus 4y cube dy by dx, right? 4y cube into dy by dx, right? So on the right hand side, x dy by dx, x dy by dx plus y. Is that clear now? So now you have to get the value for dy by dx. So keep the terms containing dy by dx on the left hand side. Okay. So the terms here are containing dy by dx. 4x square dy by dx plus 4y cube into dy by dx. Then x dy by dx. Take it to the left hand side. So it becomes minus x into dy by dx. Is it clear now? So which is equal to, now on the right hand side, you write down the terms which do not contain dy by dx. That means you should write y first, then minus 4x cube. 4x cube is taken to the right hand side, it becomes minus 4x cube, and then minus 4xy square. Minus 4xy square. Okay? So now, what is common here? It is dy by dx is taken common. So within bracket, what do we get? 4xy square plus 4y cube minus x. And right hand side, keep it as it is. That is y minus 4x cube minus 4xy square. So this is your right hand side. So what is the value for dy by dx now? So dy by dx is equal to what? Y minus 4x cube minus 4xy square. So since this is dy by dx, into is there. So when this term within bracket goes to the right hand side, you should write it in the denominator. So divided by 4x square y plus 4y cube, then minus x. Okay. So this is the final answer. So I think I've understood it. So you can copy it. Now I'll give you the homework, right? So now these are your homework. So you can do it at home. So first of all, you revise all the problems that we did today, and you can do all these problems. Okay, that is same exercise 3A, page number 292. Each question carries 2 marks. Okay, find the derivatives with respect to x. Okay, let y is equal to this is known as the explicit function. Let y is equal to, this is explicit function, and this is your implicit function. In 17 number also find dy by dx. So today we did the differentiation of explicit function and implicit function. So in the next class we will do differentiation of the parametric function. So how can you differentiate a given parametric function? Okay, so this much is for today. Thank you. So you can copy it.